Well, welcome. Hope everybody's enjoying Troopers, huh? Yeah. Excellent. All right, so I want to talk to you about the Internet of Deadly Things. What I've been working on recently, or when worlds collide, has been primarily, well, here's my disclaimer. So everything I'm talking about are my own opinions, do not represent my employer, and this is a work in progress. So basically, my journey has been from the guy that said no, started out as a hacker. That wasn't politically correct, so I rebranded myself as a researcher. I've had roles as consultants, policy scribes, architect. My new role is essentially a trusted advisor working in cyber-physical innovation. And that's been smart grid, intelligent vending, connected car, things of that nature. And I'm a part-time packet master, as Enno mentioned. So what is a cyber-physical system? Essentially, these are systems that are based in mechanical world. That would be the world of atoms. And then the cyber, and we're not going to play the cyber drinking game, although I do see somebody back there with a nice martini, that are more bit zeros and ones. And what happens when those two domains come together, there's opportunity for great innovation, but there's also opportunity for potentially very bad things to happen. So worlds are colliding, as George would say. And I want to talk about this, and kudos to Enno, who one time was talking about targeted attacks, being that there's humans involved and there's somebody on the other end of that. I've reformed type A. Now I'm kind of an empathetic person. And I understand that we really have to think about humans because these systems, presumably, are all being developed according to Ben's talk this morning, that there's some benefit to human. That's why we do it. So we'll refer to those people as the beneficiaries. And people may want to deny those beneficiaries of that benefit. But some of those benefits are money, euros, possibly health, to make life better for people, or to create leisure so that humans have more time to do the things that are important to humans. So at the center of these systems are humans, which means that we have to consider, if we have physical systems, which we think of, we like to have safe systems, and we have cyber systems or computing systems that we want to be secure. There's this other aspect here, which honestly, I was only worried about safety and security. And I guess in German, there is only one word for both of them, which I think is interesting. But I had the opportunity to have lunch with Vinton Cerf, and I'm not name dropping, it's a really great story. But he says, Grasshopper, you're forgetting about the third pillar, which is privacy. And again, I thought that was correct. So that's now been incorporated into this. But essentially, maybe we can think about if humans are in danger, this is how we can work at it. Danger of your privacy being violated, danger of cyber assets being exploited, or danger to your physical self. So we have a wicked problem. Right now, there's approximately 7.5 billion humans on the planet. By the year 2050, we will get to 9 billion, and we know we're depleting all our resources. That's not the problem I want to talk about. This is an IDC report that essentially says 4 billion of those people will be connected by 2020. We've got revenue. This is not the audience. I'm going to talk about how we can capitalize and make money on IoT or all the apps that are going to be out there. This is the number. Embedded and intelligent systems, whatever intelligent means, 25 billion plus. So this original research came out of hiding from robots and how to create killer robots. But essentially, regardless, we're going to be outnumbered very soon. And so this is not a future problem. This is a now problem. And at some point they're going to intersect and outnumber us. So there's some potential issue there. So what is a reasonable response that a security professional or an engineer or a consumer or a human should be thinking about and doing to respond to this? Well, it might be to create a cross-domain taxonomy. When you talk to engineers, I don't know if there's any car hackers here, but when we started to talk to them about why it might not be a good idea to connect the car to the cloud or have an intelligent vehicle, it's because of what potential exposure could be there. We didn't even have a vernacular to talk to them about that. And when you look at all these different domains, engineers can be great, they go to engineering school, but when you talk about a denial of service attack or why somebody might misuse a system, they just glaze over. So they have to kind of learn everything that we've learned in IT over the last 30 years. And again, they have different things that matter to them. And we're seeing that in all these disciplines that don't necessarily have intermixing or aren't cross-trained. So if we have a taxonomy, that could be a good thing, because then we could speak a common language. And it's got to be something different than when I'm talking to connected transportation versus smart grid versus Fitbit, IoT, right? So maybe it's good to have a single taxonomy. Then we can actually develop a modeling and assessment capability. Again, so we can start to develop a theoretical attack surface or a threat catalog, or here's all the bad shit that can happen if we're not careful. Agree the relevant threat catalog. Here's an important part. Ben actually touched on this, the stakeholders. So are all the stakeholders that are potentially affected by these domains colliding or these worlds coming together, are they represented? And I would suggest that they're not. So maybe that's something that we're going to have to work on. How do we create forums to bring these stakeholders together? Because it's not a future problem. The things that we're doing today will have ramifications far into the future. Once we understand the relevant threat catalog, the things that the stakeholders care about, and those will probably be different based on the community, we can articulate control affinities, countermeasures, and fail-safes. And we'll talk about those in a few minutes. And then we have rinse and repeat, because this is every time there's a delta in any one of these elements, we'll have to have this life cycle management. So you can't just fix and forget or fire and forget. So those of you out there that have been following some of the prior art, I want to give big ups to the Industrial Internet Consortium. Anybody know about these folks? They're corporations. They've done actually a pretty good job. They have a reference architecture out there that could pretty much be applied to any kind of system. The problem is I don't think they have all the stakeholders in mind, and they do have some commercial view, so I think that's influencing. But it's very good. I would suggest you look at that. Then we have NIST. I'm actually sitting on one of the working groups. It's CPS, so it's Cyber Physical Systems. If you hear me use the term CPS, that's what I'm talking about. They just published their cyber findings. This, if anybody's worked on any of these work groups before, brilliant people, they're awesome, but you'll spend 2 hours arguing where you put a comma. So not super practical for most stakeholders, and by the time they do get it out there, they're actually supposed to release something, another revision next month. I don't know what practical application it has in my day-to-day duties. And then I Am the Cavalry, who's following these guys? Okay, they're pretty awesome too. I love the way that they're using analogies from the real world. So it's all about things that will have an impact on humans. So in the connected car, they have a 5-star safety kind of program, the model. They go very high level. They're educating the industry. They're educating consumers at the very high level. They've also done this for medical devices, the Hippocratic Oath. So I love those things. Again, for my use, it doesn't really allow me to do relevant risk assessment or go into the boardroom and advise on how to make a decision between two potential options, or even how to dissect the elements. But this is all good work. I suggest you go check it out, and hopefully we can influence the NIST bits. The CPS primitives. All right, so what I've tried to do here, and the purpose of this presentation is to expose you to what I think the primitives would be for any cyber physical system. We have, at the heart of it all, there's a human. We then have a single function automaton. We have sensors that can be attached to those automatons. We then can give them communication, and we have actuators. Essentially, this is the recipe for a robot, or potentially an evil robot should we get any of these things wrong. You can imagine that adversaries can fool sensors into doing things that we won't want them to do. And then the single function automaton, maybe it's not so bad if it doesn't have an actuator that provides it mobility or can be weaponized. You could argue that once you give it a communications, then it can reach out and talk to other single function automatons, and bad things can happen there. But expanding on this, and what I'm calling danger drivers would be the addition or the understanding of an effector. So an effector is anything that can influence or trigger an actuator. So we might have multiple automaton or multiple single function automatons that become automata, which was a really good movie. I especially like the dance scene. Forget that. We then have our sensors again. So a sensor detects something. It now sends a signal somewhere. That signal actually becomes an effector if an actuator reacts to it or if another sensor reacts to it. We have operators. These operators can be human. They could also be other automaton that can trigger an actuator. An actuator, is everybody familiar with an actuator? It's something that can actually change something in the physical space. This could be effector could be physical or cyber aspect component. And we have mobility. So mobility would then could be for the whole system. Also, mobility could be used as an actuator that could hurt somebody. And then we have things that are actually designed to be weapons. So we can get more specific. So obviously, an actuator here that is used for pumping water, well, that's, if you're an engineer, that's a good thing. An actuator an actuator as a weapon, that's probably got a higher potential to hurt humans or to harm humans, or there's danger there. So relatively speaking, a generic actuator is not a weapon, but could be used as one if we don't build some controls in there. We also have this concept of level of autonomy. Level autonomy, how much autonomy will you give your actuators, or how much autonomy will you give to an operator or to a user? Then we have sphere of influence. A sphere of influence could be an actuator. So if we start thinking that we have an actuator that can move at 180 degrees versus one that can move in 360 degrees. Okay, so there's a relative way to look at the potential for harm in the sphere of influence of an actuator. Range of motion, follows the same trajectory, whereas a sphere of influence can be a level of autonomy that we give somebody. So, this operator can have a sphere of influence across sensors or actuators, and that gives them more of an effector capability. And then we have capacity. And again, when we look at capacity, that's going to be relevant to whatever the characteristic is. So if it's mobility, a car has a theoretical maximum capacity based on its fuel reserve. So confidence characteristics. If these are all the danger drivers, and we can calculate a number and look at a relative system to see how they score against each other, then we can also introduce confidence characteristics and how we might trust. And everybody understands that confidence is a combination of trust and control. Everybody familiar with that concept? So if we can tweak any of those, then we can have a high level of confidence in our systems. So again, not only danger drivers and sensors, that if I had a lot of sensors, I have a big attack surface that can be fooled. I can also view sensors as a sensor array. So I don't necessarily have to trust one sensor. I can trust multiple sensors. I can also have a level of autonomy. Do you want control or discretion over your connected car? Or would it be more dangerous to have drivers out there that can override their vehicles? Also, maturity of systems might be a confidence characteristics. We talked about discretion briefly. The idea of persistence. So what happens when a device, if it has to reboot? I think Jacob was talking about some of the issues with rebooting, satellite. And we want persistence in there, possibly, so that we go back to a known good state. We have the idea of controls in form of countermeasures. This is a big one, fail-safes. Can you unplug it? We might want to build those in. And then do you actually have a kinetic capability? Could you self-destruct it or blow it up remotely if you had to? All right, so what's next? And because I just got the 2-minute warning. I'm publishing a proper white paper in June. So I am kind of soliciting feedback if anybody has any ideas how to do this universal modeling system. We have use cases, so we have the hiding from robots, which is kind of cool. Sophie's Choice, which Ben talked about. You have a car, the brakes are out, you either hit the old lady pushing the baby buggy, or you take out the sorority girls in the car next to you, or you stop and the driver gets killed with the truck crashing in behind it. And then these ideas connected transport. So those all be fleshed out in the white paper. We also have tools. I'm applying the rapid risk assessment that was developed with ER&W, also introducing this trust-enhanced risk management tools so that we can understand what the confidence factors are. And then at the end of it, I hope to come up with a danger index, which essentially will be able to compare either total systems, because that's what CPS are, systems of systems, just like the internet's an network of networks, so that you can at least make some decisions and have a repeatable process around those. So we'll be fleshing this out in October in Dayton. So if you give me some stuff there, we can show it off. And in conclusion, don't panic. We're working on it. You can help get involved with it. It's inevitable, so prepare accordingly. That's it.